Okay, here we go on the Pythagorean Theorem. Um, there's a lot on the page, so don't be discouraged or overwhelmed. Most of it you already know. So, um, Pythagorean Theorem. There's a right triangle here with an altitude drawn. The altitude is just drawn to help us. We're really just going to focus on just the main triangle, DBC. And if you notice what I've done over on the right, this is something we already know. CB is the geometric mean, right? So this side is the geometric mean of EC, right? The piece and the whole. Just did that. Likewise, we know this one. DB is the geometric mean of the piece and the whole, okay? So those two things are important for us to reestablish for the Pythagorean theorem. Let's take a look at the fact that what I've done is I've rewritten this a little bit. I've squared both sides so that we get dB squared, right, is equal to ED times CD. And I've also done the same thing here. CB squared is equal to EC times CD. We're going to use both of these. So we're going to move these. Whoops, didn't mean to do that. Just mean to do this. Let's move this here, and let's move this right under it, okay? Now, before we keep moving, I want to remind you of something, and that's right here. Recall, if you have two things that are equal, Q and P, and you have another two things that are equal, W and M, if you think about what's going on here, we can allow Q and W added together will equal P and M together. Now we see this in lots of different ways. We've seen this, for instance, back in algebra where, let's say, 3x minus 1 equals 2x minus 1. That's actually not going to work, but we can add the same thing to both sides. We can add 1 to both sides. And what we want to be clear about is that if two things are equal and another two things are equal, right, like they are here, I can add the left-hand side and I can add the right-hand side, and they will continue to be equal. And so what I've done here is actually written this so that it's super clear that I can, right underneath this, let me see if I can erase one thing here. I can just take out that equal sign. You can see that CB squared, the left hand, is equal to the right hand, right? And we're just using, again, the fact that the geometric means of the legs are the geometric means of those pieces. Now, what's kind of cool is we're almost there. CB squared plus DB squared, which is CB, the side squared, plus the side squared. And if you remember, or if you know what the Pythagorean theorem is, you know that the sum of those two things is going to be equal to the square of the hypotenuse. And what we want to do is take a look at the fact that I can, if I take this out, look what's happening. CD is a member of both. CD is here, CD is here, so I can factor that length out. And what's left behind is EC plus ED. And let's be very clear that a new name for EC, I'm going to do this in red because this is the big reveal, EC plus ED. EC plus ED could be rewritten as CD. So here we go. CD, which is the same CD. I'm going to rewrite this sum as CD, and so therefore CD squared, right? And putting everything back in, everything that's right here, CB squared plus DB squared is equal to CD squared. Or, as we like to say, and be really clear about this, the sum of the squares of the legs is equal to the square of the hypotenuse. Okay, and that is the Pythagorean theorem.